Welcome everyone to a quick overview of Unit 3, Lesson 6 from Calculus, which is all about higher order derivatives. AKA, we're taking derivatives of derivatives and maybe derivatives of derivatives of derivatives, so on and so forth. So all of the rules that we learned about, we talked about, and we kind of reviewed in 3.5 are coming back to play. None of them are going away. I just picked an easier example here and then an example here. So finding the derivatives, same as we always did, f prime of x is equal to 5x to the fourth plus 6x squared minus 1. So we just take the derivative of this for the second derivative. F double prime of x is equal to 20x cubed plus 12x, and that is it. That's all we really need to do. You may be asked to do things with this, but this is really the new stuff. We're going to end up using this in context in the next unit quite often, so it's good to get this skill down and be comfortable with it. Now, where it gets a little bit weird is when we have implicitly defined functions or implicitly defined relationships. Right here I have the equation of a circle centered around the origin with a radius of 9. Let's find the double derivative of this. So, as we did before, we're going to do 2x plus 2y dy dx, because again, whenever you take the derivative of y, you have to have the dy dx is equal to 0. We can easily solve this for dy dx. We can say that dy dx is equal to negative 2x over 2y, or just negative x over y. Not too bad. But if I want to find the derivative of this, quotient rule. So we need to draw a fish. So negative x in the numerator, y. Negative x's derivative is negative 1. The derivative of y is dy dx minus fish. So we have negative y plus x dy dx all over the denominator squared, which is just y squared. And this is what d2y over dx squared is. That notation's a little weird. So if you want to switch to using y primes here, you wouldn't offend me, but this is the proper notation for it. This isn't done though. We're not finished. And the reason we're not finished is because we have a derivative within our derivative, and that's not allowed. So what we're going to end up doing is we are going to substitute back in what dy dx is right there. We're going to treat it kind of like a variable almost. So negative y plus x all over y squared, and dy dx is just negative x over y. And we can clean this up a little bit. I don't like having fractions in my fractions, so something I'm going to do just to make my life a little bit nicer is I'm going to multiply the numerator and denominator by y, and that'll cancel that one out. So we'll have negative y squared minus x squared all over y cubed, and that is what d2y over dx squared is equal to, or the second derivative of my circle. That's it. Something that you might come across, and it's going to happen either way. You're going to have simple functions whose derivatives get more and more complex, and then you're going to have complex functions whose derivatives are going to get simpler and simpler, or just something complex getting even more complex, something simple getting even more simple. Unfortunately, it's kind of like opening up a can of worms when it comes to higher order derivatives. You don't really know what you're going to get. So good luck with your practice, and I'll see you in the next video.